Okay, good day, guys. This is the Newton second law question for the revision of grade 11 and 12. Let's cut the chase. 10 block is connected to another block of unknown mass m by light inextensible string. The blocks are placed on a rough, that means there's a friction, horizontal surface when force of 45 Newton is applied to 10 kg at an angle of 30 degrees to the horizontal as shown in the sketch below. The blocks accelerate at 2.5 meters per second square left. So guys, this is a system. Two blocks are attached. We call that as a system. They have one acceleration, one tension, but the tension is in opposite direction. So the system accelerates in this direction, and then we're going to choose this direction as positive, and then that one will be negative. Remember guys, when an object is pulled at an angle, if you look at the 10 kg block is pulled at an angle, there will be components there. It's pulled, there will be a horizontal component in that way, we call it fx, and there will be a vertical component, we call it fy, right? Now it's very important to understand the forces that are acting there. In the 10 kg, the other forces, it's a normal force, it's a gravitational force, and it is a tension force in that direction. So the tension force will be negative, and also as well, since it's moving to the left, there will be a what? A friction. So a friction will be negative as well. Let's look at the mkg with an unknown mass. There's a normal force, there's a gravitational force, and there's a frictional force since it's accelerating to the left. There's a frictional force to the right, and the tension force that is positive to the left. Guys, it's raining outside, so the rain, it's gonna make a sound. Let me talk louder. Now in the statement below the diagram, it says the block of mass m experiences a constant frictional force of magnitude of 1 Newton while it's moving. So the block m, it has the frictional force, as we're told today, it's 1 Newton. We're given the magnitude there. So in the 10 kg block, we're not given anything about the friction there, or the coefficient of kinetic friction there. Guys, let's cut the chase and go to the question and answer the question. 2.1, it says draw a label free body diagram indicating all the forces acting on the 10 kg block. Guys, I already drawn the force diagram of the 10 kg block, so I will advise you to use the components instead of the force applied, because the components, they assist you in terms of calculations. So we'll represent a block, 10 kg block, by a dot, and we have a normal force and we have a gravitational force there. Now we have a tension in that direction and a friction. Now we have another horizontal force, which is, it's going to be what? Fx. It must be bigger than the combination of the opposite force, which is the tension force and the frictional force. Guys, remember, when an object is pulled at an angle, just as a reminder, your normal force is not equal to the gravitational force only. Your normal force is equal to Fg minus Fy. The minus, it's when it's pulled. So we associate pulled and subtract. When you're pulling, it's like you're subtracting, right? That's a magnetic way to remember that. When an object is pulled, your Fg is equal to Fg minus Fy. So the Fg becomes mg, and the Fy becomes F sine theta. Guys, this is what was needed in the question. That was just a reminder. 2.2, I'm not going to waste time by the definition of the normal force. Check the exam guideline. 2.3, okay, let me say it. A normal force is a contact force that the surface acts on an object, and it acts perpendicular to the object. Okay, 2.3, calculate the magnitude of the normal force acting on 10 kg block. What I've just reminded you there, guys, it will help you in this. So you'll say Fg is equal to, sorry for that, normal force is equal to Fg minus Fy. So it will be mg F sine theta. The mass there is what? Is 10 times 9.8 minus our force there. The force applied is 45 sine 30. So if you punch that in the calculator, you get the answer. That is 75.5 newtons. Next. Okay, 2. Before we go to 2.4, there's a statement there that says the coefficient of kinetic friction, which is mu k, between the 10 kg and the surface, it's 0.25. That's the coefficient, guys, which is, we call it mu k. We're given there. So the mu k of the surface here is it's 0.125. So it says calculate the mass m. Guys, there, if you're looking at the mass, and also we'll use the simultaneous equation. Guys, let me show you this. Guys, here they're looking for a mass in 2.4. This is what you're going to do. Yeah, this is what I wanted to say. If you use the formula that says F net is equal to ma, right, you have the acceleration. You're looking for a mass. Do you have an F net? No. So we can't just do that alone. We have to have two equation, which is the simultaneous equation. So you have to create equation for each block. So I will start with the 10 kg. I show that I'm using the 10 kg. I'm creating the equation F net is equal to ma. Now in the F net, I'm going to do the sum of the forces that are acting there horizontally, the ones that are involved in the movement, and it's going to be a positive Fx. Remember, left is positive, and your Fk, that is negative, that is going to the right, and your tension that is going to the right is equal to ma. Now there we know the Fx, it's going to be F cos theta. Since we're not given the friction, they were given mu k, so we will say mu k times normal force. Remember the normal force we calculated, so it's going to be minus t. T is an unknown we don't have. Now let's substitute in the following step. So our force is what? Is 45 cos what? 30 degrees minus our mu k at 0.125 times the normal force we're given there. We calculated at 75.5, which is this, minus t is equal to our mass there, in the 10 kg. Remember, using the 10 kg times what? 2.5. So this is what I'm going to do. I'm going to calculate the answer of this. It's 45 cos 30 minus 0.125 times 75.5. The answer of this, it's 29.5086. Remember, you're not going to round off, you're not done yet. So 10 times 2.5, it's going to be 25. And then what I'm going to do, it's the math there, I'm transposing in this to this side. So we're going to have 29.5086 minus 25. So our t, it's going to be 4.508.6 newtons. I'm not going to round off that answer because we're not done yet. That's not what we're looking for. We're looking for a mass. So we go to an mkg now. Mkg, I'll say F net is equal to ma, and then I'll look at the forces that are acting there. We have a frictional force that is going to the right, that will be negative. And what else do we have? The tension force that is going to the left, that is positive. Remember, the system is going to the left, and we chose left as positive. The Fk, we were told that the Fk there is what? Is 1. We're told there our Fk for mkg is 1. It will be negative 1 plus t is equal to, no, our m, we don't know m, acceleration is 2.5. And remember, guys, even here, we can substitute the tension. We have the tension there. We have the tension. We can substitute it there. It's 4.5086. So it's going to be 3.5086 equal to 2.5 m, and then we divide by 2.5. Okay. We said I'm punching that in the calculator now. So we have a 3.5086 divided by 2.5. So the answer there is what? Is 1.40 kg. That's our mass. That was the last question. That's it. Hope you enjoyed. Thanks. Bye.